this kind introduction and also for giving EuroHPC a platform to disseminate our activities among a very interesting stakeholder group. I'm Rene, I'm the program manager at EuroHPC, and I am responsible for the quantum computing procurement and grant activities at EuroHPC. So you might ask yourself, what has the European High Performance Computing Joint Undertaking to do with quantum computing? Because most of you are aware that there is this quantum flagship initiative that is well managed by the European Commission, and they deal with a lot of quantum computing and quantum technology activities. And where is the spot for EuroHPC in this ecosystem? So one of the, for us, most interesting branches of the quantum flagship activities is EuroQCS. QCS is an abbreviation for quantum computing and simulation, and it mandates EuroHPC to build and deploy an infrastructure for high performance computing and quantum computing. And what is meant by that? We are procuring quantum computers and integrating them in data centers. So we have selected a variety of different hosting sites across mainland Europe, and we procure different technologies for these data centers and then integrate the quantum computers into these, let's say, hostile environments at the data centers. And please be aware that we are procuring commercial products. That is, these are not lab experiments, but the companies are committed to deliver something that will work or is intended to work in a proper data center. So 1 second. All right. So the activity EuroQCS is with EuroHPC since late 2021, and we started the procurement of 2 quantum simulators through a pilot line that is called HPCQS. This project runs until late 2025, and we procured 2 systems based on neutral atoms. They are still in an analog paradigm, but they will be provided from the French startup Pascal, and we intend to integrate one in the Jülich data center and one at Gency in Paris. Both systems will be operational somewhere around December 2024, and you as European end users will then gain access on these 2 machines to test out your hypothesis, your algorithms, and whatever you want and you need to test to make quantum computing, to demonstrate that there is an advantage in quantum computing, that there might be an energy advantage or a computational advantage. Then apart from that, we have already selected 6 hosting entities. Entities is like an umbrella term. These are consortia of multiple participants. We have selected them through a call for expression of interest. So there were 6 successful applications. We are, of course, in this first wave focusing more on superconducting qubits simply because the technology has matured relatively faster than the other technologies, let's say. But there are also some very interesting platforms that we are about to procure. Just as an example, for LumiQ, maybe a lot of you know that Lumi is one of the pre-exascale systems that EuroHPC operates. It's situated in Kajani, but LumiQ will be situated in Ostrava in the Czech Republic. This is a system based on superconducting qubits in a specific star shape topology. But we're also procuring a photonic system for France and a trapped ion system for Poland. These systems will be phased in gradually. We expect the first systems to become operational somewhere around Q3 2025, and then build from that onwards. Very interestingly, we are procuring the quantum computer for Germany in 2 stages, and the latest stage is targeted with around 150 physical qubits. So we have additionally selected, or we're in the process of selecting 2 to 3 additional systems through the second call for expression of interest that has recently closed. The additional systems that we will onboard are more focused on spin qubits, and we expect them to be operational around Q2 2027. So there is one thing to procure these systems. But the more important thing also for you as end users is to put them to good use. And for that reason, we are also launching a variety of software calls, focusing both on the integration of these quantum computers in data centers, but also on software developments with respect to application, but also to middleware. Then we have an activity coming up on benchmarks. That is a particular interesting activity that we target to launch around mid-2025. And this is something that will focus on a broad variety of different benchmarks spanning from post-exascale to AI, but also to quantum benchmarks. That means pure quantum computing benchmarks, but also hybrid HPC-QC benchmarks. And you can see that we try to align these software activities with the phasing in of the different hardware platforms. So we expect the most powerful system, so that is the 150-ish qubit system in Germany, to be available late 2026. So this is when most of the software projects are just in, let's say, have reached full speed. And let me briefly tell you what is the main incentive of these different activities. So this HPC-QS project that we started in late 2021 is our first pilot project, and we procured 2 simulators, and we operate them in Jülich and in Paris. And the idea here in that project that is accompanying the procurement activities is also to develop a hybrid programming platform, and then to deploy a non-commercial cloud-based access to you as European end users. This integration project is intended to develop first proof of concept applications and some benchmarks for hybrid HPC-QC workflows, and is also intended to establish so-called high-level support teams that will actively engage with you as our end users, and will develop hardware agnostic application programming interfaces. So this is a first step to achieve this integration into data centers also on a software level. And we also expect this project that is going to start very soon to develop a harmonized resource allocation tool in the sense of an adaptation of a Slurm scheduler of that kind. And we also expect this consortium to actively contribute to standardization efforts. This is one of the key policy priorities of the European Commission, that European developed IP is then also translated into European standards. So what are we doing on a software level? We recently closed a call to search for quantum excellence centers in Europe. We intended to fund at least 2 of these quantum excellence centers. Don't get confused, these are virtual entities. Usually these are larger consortia, around 10 to 15 different participants spread all across Europe, and they will also engage proactively in community building. Now we expect more quantum-oriented application developments, much more hands-on and much more tangible than within the integration work. And we also expect the consortia to develop quantum algorithms, libraries, application software to bring all this forward, and then finally to act as one one-stop shops for all the relevant target groups. We will launch a call later this year, probably later this year, focusing on HPC QC middleware technologies. This is one of the most sophisticated calls that EuroHPC is launching, and we try to vertically decompose this activity across the full software stack. And with this activity, we try to get the integration work to full speed by trying to get the different software stacks harmonized into one. As you can imagine, all these quantum computer procurements that we do on the hardware side, they come with a dedicated software stack already. So that's the reason we have all this interface definition and all the software integration necessary before the quantum computer can be put to some good use in a data center. But we want to eventually harmonize, as I said, these two software stacks, the HPC and the QC software stack, and to have one modular and open European HPC QC software stack. So that is this is the goal that we are trying to reach here. And let me conclude this short presentation about our activities by guiding you through one of a potential HPC QC workflow. So you as an end user using classical HPC, you would log in to the classical HPC login nodes. You would find all your compiled algorithms, your programs, whatever you want to use in your home or archive files on the HPC storage that has full access to the HPC software stack. And now you would submit a job, and you would do this through classical classical SBatch managed by Slurm. The resource manager will then try to, or then offloads your computation request to kind of an orchestration device, an offloader or a daemon, who then makes a decision: is this a classical job or is this a quantum computing job? And after making this decision, and let's say your job is a quantum job, runs on the QPU and then goes into a post-processing loop by simply then bringing it back to the resource manager, and then all of this starts again. And with this, I'm more or less finished, and thank you very much for giving us this opportunity.